Welcome back to the oil drilling tutorial series. This is part 3, and so we're going to continue on where we left off last episode. We're going to go ahead and we're going to improve the drilling and fracturing rig here behind me. So let's go ahead and we'll get started. I've been working on this rig in the career build series, made a couple modifications. So we're going to go ahead and we'll kind of bring it up to speed here. Do a bunch of other things too. For example, initially what I did here in the tutorials to teach you how this worked, I made it here where I can manually control the valve. We're going to change that. We're going to allow a PID to automate the valve. So what we're going to do instead is we're going to set the temperature we want, and it is going to automatically, with a PID, modulate that valve so that it will maintain temp. I've done some further testing here, found some better ways to make sure that it always stays over 300 degrees. Again, people are having some struggles here where they I used a potato analogy. If you take the potato and you put it in the oven at 1,000 degrees for 1 second, it is not going to cook. If you take the same potato and you put it in a 500-degree oven for an hour, it is going to cook. So, long story short, what we learned last episode is you need to leave the oil in the furnace long enough so that it can actually absorb that heat from the furnace, and then it will be hot. If you let it pass through too quickly, it never absorbs that heat. It just gets a little bit warmer. It doesn't get warm enough. And so with this demonstration, as you can see, with one electric furnace, I can heat this oil up and keep it over 300 degrees and make my diesel and jet through fractioning. A lot of people have been running like up to 10 furnaces and not getting that temp because they're not leaving it in there long enough. So what we're going to do is automate a bunch of these systems. What we'll go ahead here is we'll configure our panels first. So we'll come over here, and instead of valve percentage, this will be set temp. So this is going to be the temperature we want to set. And we're going to go up to 320 degrees. So that'll be our max temp on there. And so now what we'll do is with our two buttons here, we're going to set the desired temperature we want, and we're going to let the PID control it. So we'll go ahead and we'll come in our microcontroller here. All right, so right here we have our up-down counter. This used to set the valve percentage. So it's a very small number here in the increment because we're setting a valve from 0 to 1. We're going to be going up to 320 degrees, so we're going to do an increment of 0.1. Reset value is going to be 310 degrees, so we want to be over 300 degrees, so it'll be 310. We're going to enable our clamp, and we'll do a maximum. We'll go up to 320, and we'll set 0 there. We're probably never going to go below 310. We'll probably just leave the system, but this will allow us to have some variability in there. All right, next thing, we're going to PID control this, so we'll disconnect the valve, and we'll type PID for PID, and we'll grab the advanced PID controller. All right, so this is going to be our set point. We're setting what temperature we want. This is going to go out to the valve after we put it through a clamp, and then we need to do our process variable. Our process variable is going to be our temperature. Right here, because we changed this from percentage to degrees, we need to go down here to make sure the gauge reads right. We're just going to delete that times 100, and that's just going to read out the value on the on this. We can actually just go like that, and now this is going to read us what our set temp is. So that's our second number on our dial. Next thing we need to do here is, I already did some testing with this. We have some variability with this, and so what I'm going to do here is we're going to grab a function. It's going to be a function XYZ. We'll plug in the PID into this, and then we'll plug that into the valve. We'll just give it a little bit of space here. And what we're going to do here is we're going to do some property numbers. The first one is going to be the minimum valve. All right, so the minimum valve here, I've already done some testing. 0.2 is working pretty well. If we go below that, it is not letting enough hot oil in. It will take a little bit of time to heat up. So 0.2 is a good value. And then we'll go ahead, and I'm just going to go up to about 0.3 on this. So 0.3, and that's going to be the max valve. So that's the maximum value on the valve. So we're not going to go 0 to 1. We don't want the valve to completely close. We don't want the valve completely open. We want it to constrict the flow so that the oil has time to heat up in the furnace. Next, we're going to go in here. If we go to add-ons, as you see, we have clamp down here. So we're going to go ahead and we're going to put a clamp in here. So we'll do clamp, parentheses, X is going to be the value coming out of the PID, comma. Y is going to be the minimum value, and then comma Z. And what this is going to allow us to do is with the property numbers, we can easily change these without having to go into the microcontroller. So those are all in there. That will clamp this out where it needs to be. Up here we have the furnace and pumps. This will turn on our furnace and pumps, and we're going to go ahead and we're going to utilize this to connect it and start our PID. All right, next thing we're going to do here is we're going to go to Design, Properties, and I'm going to make this taller, and we're going to add just one node. You can do a P, an I, and a D if you want. If you want to get your number ultra, ultra, ultra precise, you can do this, but you do not need to. A lot of people are doing this, and you really don't need to. You don't need your temperature within 6 digits of where it needs to be. As long as it's within a couple degrees of where it needs to be, you're good. You don't need to be ultra precise. All you're doing is spending a bunch of extra time. If you want to do it, be my guest. But you don't have to. So that's going to actually be a number input, rather, for the P. And so we'll take this here, and we can tune our p-value on the fly. That's why I like these advanced P's. So we're going to plug these advanced PIDs. We're going to plug that p-value in there. All right, now I already know something else we need to do, but I'm gonna show you how this works first, and then we can automate that part of the system as well. So let's go ahead and we'll update this. All right, next thing we need is a keypad. So we'll put a keypad in here, and we'll just color it pink so we see it there. Now we'll put this in here. This will be to control that p-value. So we'll plug the electricity in, and then we'll go ahead and we'll connect that to the p-value there. All right, I'm actually going to change this. We'll call it p-value. If we look here, as you can see, because we did property numbers, we have our minimum valve value, and we have our maximum valve value right there. And I'm just for make it a little bit easier for you guys to see it here, we'll do p-value. All right, good. So that's just a little bit more explanatory there. All right, and then this will be the p-value here. All right, so this is all plumbed in now. So this will automate the valve, so the PID will automatically control it. So let's go ahead and we'll spawn the rig. All right, so the first thing we want to do here is we want to make sure that the valve is moving in the correct direction. We want to make sure our PID is going the right direction. So we'll go ahead and we'll connect our pipe here. We'll go ahead and we'll turn on the pump. Now we're starting to pump oil. We'll verify that. As you can see, yep, plenty of oil. We're going to go over here, and we're just going to set a p-value of 1. And the first thing we need to do is make sure that our valve is going in the right direction. So remember, we want that potato to spend enough time in the oven. We want the oil to spend enough time in the furnace to actually get some heat. And that we're doing that by reducing the valve. So the smaller the number, the more time it has in the furnace. The bigger the number, the less time it has in the furnace. So bigger number, colder, smaller number, hotter. To an extent. That's why we're capping it between 0.2 and 3. Of course, the smallest number of 0, we're going to get no heat. So we're going to go ahead and turn the system on, and I'm going to check it. So let's go ahead and look at the valve. As you can see, it's at 0.3, right? It should be at 0.2. It's backwards, right? So sometimes this happens with PIDs. One thing we could do is we could go back in there and we could invert the number, or we could do this. Instead of a 1, let's do a -1. So we've gone to -1, and let's look at the valve. It should be 0.2, and there it is. So now we're at 0.2. So if you ever get this problem where your PID is backwards, you can use a negative number like that, or you could invert it with a -x. So now we should be heating up. As you can see, look how fast we're heating up. We're already at 120 degrees. So let's go ahead, and I'll check back in with you guys when we're around 300. All right, so there's 300. So this is going to automate the PID. So the PID is going to automate the valve. So once we start getting up over 310 degrees, it is going to start to modulate the valve. It will start going more towards 0.3 to cool us down. It will go back down to 0.2 to warm us back up. And so what we want to do is we want to tune the p-value of this and check it. So there's 310. Let's see what it did. Instantly went over to 0.3. So let's just keep an eye on this. As this cools down, it's going to probably flick back to 0.2. So likely this number is too fast. Or the p-value is too high because, there it goes. It just flicked over to 0.2. We don't want it to be an on-off switch. We don't want it to go 0.2, 0.3. We might as well do a numerical switch box at that point. So what we'll do here is let's go over here and let's half this number. So let's do -0.5, and let's check and see how that behaves now. So there's 300. We're starting to cool off. There's 2. Let's see how this behaves. Okay, so you see it's more slowly oscillating the valve now. It's not going 0.2, 0.3, 0.2, 0.3. It is slowly changing the valve so that it can try to maintain that temp. And so this is the number that I came up with that works pretty well. As you can see, we're holding a nice consistent temperature. But when we turn on the jet fuel and the diesel pump, we're starting to pump hot diesel and hot jet fuel out. As you notice, we have no oil. It's already been converted to diesel and jet fuel. We're pumping away our hot diesel and jet fuel. Watch what happens to our temperature. Now think about it. You have a nice hot pot of water on the stove. Right? It's at 310 degrees. You then go to pour it out in the sink. Well, guess what? As you pour your hot liquid away, it's going to drop the temperature because that liquid is helping to maintain the temp. So we'll keep an eye on what this temp does. As you can see, we're pumping our diesel and jet out. Let's go ahead and take a look. As you can see, it's going in there. There's our jet fuel. Here is our diesel. We're pumping away all that hot liquid. We're pouring the hot pot out of the, we're pouring the hot water out of the pot. And you'll notice our temperature starts to go down, okay? This is why we get that oscillation where it goes over 300 degrees, then it goes down below 300 degrees, is we're pumping out the hot diesel and jet fuel faster than we're putting in new stuff, and it is cooling it back down, okay? So let's keep an eye on this, and we'll see that it drops below 300 degrees. So there's something we can do to make sure this doesn't happen. So let's let it get all the way down below 3, as you can see. So a lot of people might be like, it doesn't make sense, we're losing this. It does make sense. You're continually adding some water into the pot, but you keep losing your hot water. It is going to keep dropping the temperature, and that's what's going on here. So as you can see, we are going to dip below 300 degrees. And here we go. We're going to drop below 300 degrees, and watch as the diesel and jet fuel starts getting converted back into oil. So you see they're getting converted back to the oil. We don't want that, but let's do this. Let's shut off the jet fuel and the diesel pump and watch what happens. Now, we're not losing that hot diesel and jet fuel anymore. That hot diesel and jet fuel is staying in there. It's acting like a blanket. So as we put in new hot oil, it is staying in there and it's acting like a blanket to maintain the hot temperature. All right. So now, there it goes. It's heating back up. So we're going to put an automated system in here that there'll be a condition that the diesel and jet pump will only work when this is over the set temp. All right, so let's go ahead and add that in. So we found out that negative 0.5 is a good p-value for our PID. So let's go ahead and shut the throttle down. Let's disconnect. Make sure you disconnect if you're gonna, despawn this so you don't lose your drilling rod. All right, so let's go in here. And now that we know that negative 0.5 is a good number, we can get rid of that keypad. Now, I'm going to leave it in case you guys want to play with the number, so that will stay in here. I'll just put this up here. This will be the p-value right there. I'll actually, we'll change the name so you guys can find it if you want to play with it. So this is the p-value keypad. All right, so that's a p-value keypad. If you want to re-plug that in, you can, but what we're going to do is we're going to take a property number. We know that negative 0.5 works well, so here is the p-value. I don't need the I or the D. Could I make it ultra precise down to 6 decimal places if I use the D value? Absolutely. Do I care? No, I don't need it that precise. I really don't. All right, so we're going to do negative 0.5. So that's going to be set in there. So we'll be all set there. Now what we'll do here is composite 9 and 10. These are the 2 buttons we have to turn on the pump to pump the jet fuel from the fractioning tower into the storage tanks, and the same for the diesel. What we're going to do here is we're going to add an AND. So we'll go ahead and we'll add an AND right here and in there. So we'll go right there for this one, and we'll actually just move this down here so we have space. Grab another AND here. This will go right there. All right, good. And so the AND condition is going to be and the temperature is greater than 310 degrees, or it's the set temp. So what we'll do here is we'll do greater, and where are we at here? So we'll find our set temp. So this is our set temperature right here, okay? So if the temperature is greater than the set temp, so if the temp right here, the temperature of our fraction tower is greater than the temperature we set, and the buttons are on, it's going to it's going to turn those pumps on and allow the diesel and jet to go out. Again, this is like a blanket, right? The diesel and jet fuel are helping to keep everything warm. If we vent them out too quickly, what it's going to do is it's going to allow it to cool down. So this is trying to increase our thermal efficiency. This is trying to keep that liquid in there longer so that we don't lose that temperature. So what it's going to do is it's going to oscillate the diesel and jet pumps so that it only lets the liquid out when we're hot enough. And this will keep it from going below 300 drop me below 300 degrees, and we end up not fractioning anymore. And the diesel and jet will reconvert into oil. We don't want that. We don't want it to convert back. So we're going to go ahead and we'll update this. Now, this system is mostly automated, so let's go ahead and spawn it. All right, so we're spawned in here, so let's go ahead and connect it up. Most of the things here are going to be automated. Now, it will automate the valve here with the PID. And what it's going to do is it's going to automatically close and open the jet fuel and diesel pumps, and so that will maintain our temperature. So we're starting to pump here. I'm going to turn this on, and I'm going to start a stopwatch. So we'll see how long it takes to get to 300 degrees. All right, so here we are. It's taken me about 3 minutes and 10 seconds to warm up to 300 degrees here. So there's 316 as we hit 300 degrees. So not that long. Let's go ahead and we'll turn on the jet pump and the diesel pump. Now remember, this is only going to pump when we're above 310 degrees. So as you can see, it is accumulating. We're not pumping. We shouldn't have any in there because we're not at 310 yet. As you can see, nope. And so this is only going to allow the pumps to actually turn on when we exceed the set temperature. So this should maintain the temperature over 310 degrees. As you can see, it's going to go down. We're going to pump out. And then as soon as it dips below 310, the pumps are going to automatically shut off. So they should be on right now. So let's go ahead and take a look. Yep, we're pumping. Let's go ahead and take a look at this now. As you can see, eventually it will try to dip below 310. It's starting to get close. There it goes, and the pump should be back off. Yep, pump's back off. And let's look at what our temp does. Our temp rose right back up above 310. So it makes perfect sense. If you think about it, that's thermal efficiency. The hot diesel and the hot jet fuel are helping to maintain your temp. And because you're pumping away the things that are helping to maintain your temperature, it is causing the temperature to drop down. Now, the system worked. I had this system running in my career build series, live series, and I was very quickly filling these 2 tanks up. So it's not a problem if it dips down. So the old facility works fine, but this one works better. And so that's what we're going to do, continue to improve upon this as I work on it. So as you can see, we're maintaining our temp really well now. We have no problem staying above 310. We probably could crank it up if we wanted to, but we don't have to. You know, as long as we're over 300, we're fine. So now, as you can see, we dip below, and look at that, go right back up. And so this is one of the issues that some people might be having, is if you're pumping off that diesel and jet fuel, you will be losing temp. It does make sense. It is logical. You're losing that thermal efficiency of having good hot oil, diesel and jet fuel that help maintain your temp. So real simple system here, and as you can see, it is working really well. No issues here whatsoever. So this will be connected here. You can play with p-value. You can reconnect it if you want, but it is all set up and working. So let's do one more thing before we go. I already did this on my rig that I use in the career build series, the live series. And so what we're going to do is we're going to do pump out. So we'll be able to pump out our diesel and jet fuel and put it into, for example, a truck. So let's go ahead and get working on a couple other things. So right here, if we look, we have a fluid port that's coming down. We could put a liquid relief valve on here if we wanted to just make sure this was only ever going to pump out liquid. I think it's a better thing to pump some liquid and air together, and the reason is this. It prevents any clogs. You're going to have to vent your truck anyway, so I kind of like to pump a little bit of air with it anyway, so I don't bother putting in a liquid relief valve here. And so I'm just going to go ahead and we'll put a large pump in here just so that we pump a little bit faster and at a higher pressure. So we'll put that in there for our diesel, and we'll put one in here for our jet fuel. All right, good. And now what we'll do is we'll build a little stand over here, and this is where we'll plug our truck in, and this will allow us to get our fuels out. So we'll go ahead and just build a little stand here, kind of like I did on the career build series, the live series. So let's go ahead and we'll put our hose anchors here. All right, so we'll go ahead, and that is 1 and 2 there. So I like to color code them, so we'll go ahead and we'll make that blue, and we'll make this one yellow. Those are the official colors for diesel and jet fuel here. Go ahead. All right, good. So that's all plumbed in, so we can get our diesel and jet out. Let's go ahead and we'll grab a panel. I'll make a quick and dirty microcontroller here. So this is going to be right here. This will be jet. I'll do a button that way we can see it. It's going to be toggle channel 1. All right, so let's go ahead and let's test this system out here. We just want to make sure the pumps turn on and off, and I think we'll finish it up there. And I will be continuing the series. We'll continue on improving it as we go. So let's go ahead and we'll spawn it. So what we'll do in further episodes is we can automate this pump so it automatically shuts off. Let's go ahead and turn that on. All right, good. We're pumping oil. As you can see, there we're pumping oil. All right, good. Turn that system on too. And we should be able to read that these are diesel and jet. Let's go ahead and press the two pumps, make sure they are working. So that's the jet fuel. Yep, it's pumping. This is the diesel pump. Yep, it is on. So those are both on. So if we wanted to pump out into a truck like I do in the series, we can do that. You see those are 0 for right now, so let's go ahead and check them out. I did not index the gauges. We'll do that before we leave. But as you can see, it only takes a couple minutes, so I'll check back in with you guys when we get there. All right, so here we are approaching the 300-degree mark. We'll go ahead and we'll turn on the diesel and jet, and we'll just make sure those these two gauges are working here. So we'll shut those pumps off, and let's go ahead and watch, see if these are filling up. I probably didn't connect them up. Let's check. Not pumping yet. So once we get over 310 degrees, remember that's when it'll start pumping. So we'll actually, let's back up and let's watch from here. And this will read out in the gauges for us. So tell us if we're getting, and there we go. So they're filling up. So as you can see, system is working great now. So, you know, to recap really quickly, again, you need that baked potato to stay in the oven long enough to heat. You need the oil to remain in the furnace long enough. So what we did in this episode was add a PID to it. So now instead of us manually controlling the valve, we can set the temperature we want. We can go away, we can leave, we can go do missions, and this system will automatically run by itself. If you pump out your diesel and your jet too quickly, the temperature is going to drop, and it makes sense. Again, you pour out some of the hot water in the pot, it's going to take longer to reheat the cooler oil again. So that will continually slow the heating process. As you can see, we're consistently and constantly and always maintaining a temperature over 300 degrees here. And so this system is working really, really well. There will be some more episodes in this where we continue to refine this, automate the pump, and do a bunch of other stuff. So I hope you guys found this helpful, and I'll see you in the next one. Bye.